We start with a point. Hi, it's Rob Bryanton, and today's entry in the Imagining the 10th Dimension video blog is called The Flexi-Laws of Physics. One of the ideas that relates very strongly to our recent discussions here at Imagining the 10th Dimension is the experimentally observed proof of what is known as Wheeler's delayed choice experiment. Amazingly, this proof confirms one of the ideas we've talked about a lot with this project, that the branching possibilities that we as quantum observers make can select not only different paths within the future, but retroactively change things in the past as well. While there have been a number of different experiments conducted to demonstrate Wheeler's concept since he first proposed it back in 1978, it wasn't until 2007 that the first clean experimental test was performed in France by the team of Alain Aspect, Philippe Granger, and Jean-François Roche. The diagram that we're looking at here shows a version of Wheeler's delayed choice experiment. In a nutshell, it is based upon the classic experiments with photons passing through either one slit or two. And the confounding but well-known result of these demonstrations is that photons can be shown to be a particle or a wave depending on whether they pass through one slit or two. Wheeler's proposed experiment then was based upon not selecting the one slit or two slit path until after the photon had passed by. And Wheeler's seemingly counterintuitive result he was proposing is that the photons will still demonstrate the properly corresponding wave or particle pattern by the time they then arrive at the final detector screen. It's as if the photons go back in space-time and choose to behave in the correct manner, as if the one slit or two slit pattern had in fact been there when it wasn't. The explanatory diagram we're looking at here was attached to a New Scientist article published 2 years ago, written by physicist Paul Davies. This much discussed article of his was called The Flexi-Laws of Physics, and I'd like to quote some from that article. Science works because the universe is ordered in an intelligible way. The most refined manifestation of this order is found in the laws of physics, the fundamental mathematical rules that govern all natural phenomena. One of the biggest questions of existence is the origin of those laws. Where do they come from, and why do they have the form that they do? Until recently, this problem was considered off limits to scientists. Their job was to discover the laws and apply them, not inquire into their form or origin. Now the mood has changed. One reason for this stems from the growing realization that the laws of physics possess a weird and surprising property. Collectively, they give the universe the ability to generate life and conscious beings, such as ourselves, who can ponder the big questions. If the universe came with any old ragbag of laws, life would almost certainly be ruled out. Indeed, changing the existing laws by even a scintilla could have lethal consequences. For example, if protons were 0.1% heavier than neutrons, rather than the other way about, all the protons coughed out of the Big Bang would soon have decayed into neutrons. Without protons and their crucial electric charge, atoms could not exist and chemistry would be impossible. Physicists and cosmologists know many such examples of uncanny bio-friendly coincidences and fortuitous, fine-tuned properties in the laws of physics. Like baby bear's porridge in the story of Goldilocks, our universe seems just right for life. It looks, to use astronomer Fred Hoyle's dramatic description, as if a super intellect has been monkeying with physics. So what is going on? A popular way to explain the Goldilocks factor is the multiverse theory. This says that a God's eye view of the cosmos would reveal a patchwork quilt of universes, of which ours is but an infinitesimal fragment. Crucially, each patch, or universe, comes with its own distinctive set of local bylaws. Maybe the bylaws are assigned randomly, as in a vast cosmic lottery. It is then no surprise that we find ourselves living in a patch so well suited to life, for we could hardly inhabit a bio-hostile patch. Our universe has simply hit the cosmic jackpot. Those universes that can't support life, the vast majority in fact, go unobserved. Keeping in mind that this article was published 2 years ago, one of the things that has changed since then is there are many more mainstream physicists willing to accept the idea of this multiverse of universes, each universe having its own unique set of basic physical laws, and all of those universes just as real as our own. We talked about this change, for instance, in Does the Multiverse Really Exist? Later in the article, Dr. Davies says this: 400 years on, physicists still cling to this model of physical law, even though they have no idea what the external source of the laws might be. So long as science appeals to something outside the universe, we must abandon any hope of ultimately understanding why the universe is as it is. A large element of mystery will lie forever beyond our reach. There is, however, another possibility. Relinquish the notion of immutable, transcendent laws and try to explain the observed behavior entirely in terms of processes occurring within the universe. As it happens, there's a growing minority of scientists whose concept of physical law departs radically from the orthodox view and whose ideas offer an ideal model for developing this picture. The burgeoning field of computer science has shifted our view of the physical world from that of a collection of interacting material particles to one of a seething network of information. In this way of looking at nature, the laws of physics are a form of software or algorithm, while the material world, the hardware, plays the role of a gigantic computer. Does this sound familiar? Regular readers of this blog will recognize this constantly recurring refrain: information equals reality. The article then goes on to state ideas very similar to what we've been talking about lately with discussions of the biocentric universe theory, that the ability for observations now to change certain things in the past could be extended all the way to the idea that the emergence of life actually fine-tuned things about our universe, changing those Flexi-Laws of the indeterminate beginnings of our universe into more locked-in laws. But the actual locking in doesn't happen when life begins. Rather, through the process of retrocausality, it occurs back near the beginning of our universe. Again, these are ideas we've talked about from a number of perspectives in my book and this blog, but it's always nice to see mainstream physicists showing that these ideas are not as crazy as critics of my project have been claiming. Paul Davies then goes on to explain how the verified proof of Wheeler's delayed choice experiment confirms that it is possible for observations made now to affect the past, and ends with this concluding paragraph. In the orthodox view, the laws of physics are floating in an explanatory void. Ironically, the essence of the scientific method is rationality and logic. We suppose that things are the way they are for a reason. Yet when it comes to the laws of physics themselves, well, we are asked to accept that they exist reasonlessly. If that were correct, then the entire edifice of science would ultimately be founded on absurdity. By bringing the laws of physics within the compass of science and fusing nature and its laws into a mutually self-consistent explanation, we have some hope of understanding why the laws are what they are. In addition, we can begin to glimpse how we, the observers of this remarkable universe, fit into the great cosmic scheme. Paul Davies is director of Beyond, a scientific think tank at Arizona State University. His latest book is The Goldilocks Enigma: Why is the Universe Just Right for Life? In the US, it's called Cosmic Jackpot. Next blog, we're going to continue this discussion of where the basic laws of our universe come from as we look at an article written by cosmologist and astrophysicist Martin Rees. Other blogs where we've talked about retrocausality and causal chains extending both forward and back from our now include The Long Undulating Snake, The Big Bang as an Illusion, The Biocentric Universe Part 2, and John Wheeler and Digital Physics. And next item is going to be called Alien Mathematics. My name is Rob Bryanton. Enjoy the journey. Hi friends. Due to popular demand, the book that started this project, Imagining the 10th Dimension, is now available as an audiobook. This set of MP3s totals over 6 hours and is the revised and expanded 3rd edition of the book. Go to 10thdimension.com/digital.